So in this video, we'll look at how to make aluminum from alumina. So alumina is a mineral, so it's essentially aluminum oxide, and it can be electrolyzed and turned into aluminum and oxygen. The oxygen comes off as a gas. The aluminum under these conditions actually is so hot, it will actually melt and form a liquid. And we can balance this equation by putting a 3 here and a 2 here. And I guess that would mean a 4 here. So here's a question for you. The question is, how long would you have to run a 50 amp current, so a 50 amp electrolysis current, through molten alumina, okay, to make, let's see, how much should we make? 125 grams of aluminum. So maybe you can go ahead and pause the video and see if you can get that. So how long would you have to run a 50 amp current through molten aluminum or alumina to make 125 grams of aluminum? So pause, unpause, we'll go through it together. All right, so I guess we probably need to start off by considering the chemical equations. So what do we have here? So alumina is essentially made up of aluminum ions and oxygen ions, and the aluminum ions are being changed to aluminum. The oxide ions are being changed not to oxygen atoms, but oxygen molecules. We can balance those equations, so we don't really have to pay attention to this overall balanced equation necessarily. We can balance those equations just like we balance redox. We balance using coefficients, and then we're just going to balance using charges. So let's see, we got aluminum 3 going to aluminum, so we got to add 3 electrons to the left side. So remember, we added to the more positive side. However, here we've got 4 negatives, so we need to add it to the more positive side to balance it out. So we need 4 negatives on the right-hand side. And yeah, if we wanted to add these together, we'd have to quadruple that and triple that and add it together, but we really don't need to do anything more than that. So why is that? Well, we're trying to make 125 grams of aluminum. So I'm going to go ahead and I'm going to start with the grams of aluminum. And my plan is to take grams of aluminum and convert it to moles of aluminum, convert it to moles of electrons, and then convert it to charge, and then convert it to time. So that is my plan. I think we know how to do that now, at least I hope so. There's a couple of ways to do this, but we can do it all as one conversion problem if we want to. So grams into moles, so we just need to look up the molar mass of aluminum, which is 26.98 grams per mole. All right, now we need to look at the balanced chemical equation. We can see that every time we make an aluminum, we need 3 electrons. So we've got that 3-to-1 ratio. So we've got 3 moles of electrons. Probably should have started with the 1 mole of aluminum on the bottom to show it canceling. So let's cancel, 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 cancel. We got moles of electrons. All right, we've got to turn them into a charge. So we've done this, we've done this. How do we do it into a charge? We remember the Faraday constant. So there's 96,500 coulombs every time you've got a mole of electrons. So we cancel moles of electrons. That gives us coulombs. And charge into time. Okay, so we can do this as an equation, or we can do it as a conversion factor. We know that 50 amps means there's 50 coulombs in a second. So we can go ahead and we can just write that in such a way the units we don't want will cancel. So we put the coulombs on the bottom, the seconds on the top. And let's see, coulombs, coulombs. So seconds are on the top. So let me go ahead and just erase, give us some room. So we plunk those numbers on our calculator. And we get a very big number. So to 3 significant figures, I get 26,825. So 800 seconds. And if I take my calculator and I divide it by 60, it'll give me minutes. Divided by 60 again, it'll give me hours. So we are talking about 7.45 hours. So it's taken almost 8 hours to produce a mere 125 grams of aluminum. So that's what, like a third or a quarter of a pound, an eighth of a kilogram. And so aluminum takes in an awful large amount of electricity to produce. And so they're often situated, these kind of plants that do this, right next to waterfalls or rapidly moving water. So you can generate hydroelectric power to run these reactions. And so hydroelectric power is a very cheap way to generate electricity. And so you need an enormous amount of electricity to make just a small amount of aluminum. And yeah, so aluminum is kind of tough to make any other way.